Hello, this is my Cycle 7 project for CSC 842. This is another Scapy project. I initially was not going to continue with Scapy for this cycle, but based on the feedback from Cycle 5, I got so many good ideas from my fellow students that I thought, okay, I'll do one more round of Scapy, and this will be the last Scapy project, and then I'm going to do a different type of project for Cycle 9. But anyhow, we're going to run through the source code here and see what's new. First thing we notice is that this file has been formatted with black, which is a program available from GitHub, and it provides standard formatting for your code. So no matter how sloppily you write your code, once you run through black, it all has this nice, neat formatting and indentation, and it looks somewhat professional anyhow. So I would thank my fellow students for suggesting that. Another suggestion was to modify the code to use classes. As this course has gone on, I received a number of good suggestions from Mr. Ryan Hoy and others who have offered constructive criticism of the code I've written, and as a result, my Python skills are actually getting better as the term goes on. I mean, they're still not great, but I've noticed some improvement. And one of the things I've learned to do is use the class construct here in Python. And I've set up a couple classes. This is a target of a scan target. And the other one is SynScan down here, which is how to do a scan actually. Other changes is that the for loops now go in the form, they're using the range construct here, range, to go through and using the in keyword, as you'll see in some other for loops. For example, here for port in tokens. All right, it runs throughout each token. One of the things that was suggested was, instead of having the user specify a target IP or target domain to run a scan on, could we specify those in a data file and have the program read them in? And so I've done that. I've added that capability, and we'll see a demonstration in another video. But here is a data file which consists of lines where each line is an IP address or a domain name, and then a list of ports to scan for that address. You've noticed also that each line that begins with a pound sign, or an octothorpe as it's sometimes called, is a comment line. So you can put your comments in here. I put in the format of how to add lines to the file, and this particular file is going to run 2 scans. It will scan this IP 151.101.6.187, which is actually the IP for target.com. And it'll also scan the domain name www.cnn.com, and it'll scan these ports. I picked them at random. So, going back to our source file, things to note in here. As I say, we've reorganized the code. We have classes. I'm learning to say if condition is not none as opposed to if not equal none. That's a little bit better Python style, I believe. Most of this you've seen before, but there are some changes. One of the changes having to do with reading in the file itself. All right, let's take a look at that. When we get our command line arguments in, we want to know if the user has specified that the targets should come from a file. And we do that by checking the file name argument, which is a new argument here. So if that's not none, if they specified a data file, then we're going to read the file, and we split each input line into tokens. All right, remember what our input lines look like over here. It's either an address or domain name followed by a list of ports, or it's a line that starts with a £, which is a comment line. So what we do is we split our lines into tokens, and then we look at each token and says if it does not start with the octothorpe, in other words, if the line is not a comment, then go ahead and take that line and build a scan target from it. In other words, a target IP or domain and a port list to scan. And append that scan target onto a list of scan targets that we're going to scan. Close our file. This is just exception handling if we get a bad file name or something, want to report that we had a problem. If the user did not specify a file name, then we know that our target is specified on the command line, and we build our port list as we did before in cycle 5, and we create a scan target from it. But in this case, we only have one scan target because there's only one IP or domain name specified on the command line. So our list of scan targets in this case is only going to have one target in it, whereas in the case where they specify a data file, it could have multiple scan targets, one for each line of the file. All right, so that's how we build our list of scan targets. Now we have to run the scan, and all it is running through the list of scan targets. All right, self.targets. I call it scan target in this for loop, and run through our SYN scan as we've done earlier in the term. There is a change further down, but I'll show it to you in a minute. This is basically our same code here, but when we get down to our arguments, naturally we've added the ability to add a file name, so that meant adding additional command line parameter. And that's our file name parameter, and then he is here, file name. And his short form here is N because I was already using F for something else. We also have added the capability to specify a list of ports to scan for each host. When you're running the traceroute option and you want to run a traceroute and then run a SYN scan on each host in that traceroute, and we've had that capability before, but now we've added the option to specify which ports to scan on those hosts in the traceroute, and that's what this rscan ports option is down here. And we've also added the capability to specify where to go. We've also added the capability, which I guess I'll find in a minute, of just specifying the type of packet. In other words, we need to have the capability to, say, investigate a LAN. In other words, I want to go out and on a given subnet, I want to find out what hosts are up. And we do this by adding a ping mode to it. And we'll either send an ICMP ping or a UDP ping, and that's specified as packet type parameter, ICMP or UDP. And depending on what the user enters, we will send a packet, an ICMP or UDP ping to each host on a /24 subnet, so basically a local area network, and report which hosts are live. And we'll see that a little further down the code. Running the trace route is as before. There isn't anything new there. Still operates pretty much the same way. The route scan operates the same way, but we have added this ping capability, and this is what I wanted to show you. Again, it looks through the local LAN and ICMP or UDP ping for each host in a /24 subnet. So what we do is we take a target from the command line. We take the first 3 octets of it, and that's our subnet, and then we are going to perform either an ICMP or a UDP ping on that subnet. And here's how we do it. We look at what packet type the user specified. If it's ICMP, we create an ICMP object, ICMP packet object. Otherwise, we're going to use UDP, and we're going to give it this bogus destination port of 0, because port 0 should be closed, and if our host is alive, it will return host unreachable, which leaks the fact that the host is actually up because it responded. We check, when I say we check the whole subnet, we check addresses in the range 1 to 253. It won't actually check address 254. I didn't see a point in that, but 254 and 255. But it checks host 1 to 253, and we use a SCAPI function called SR1 here, which is again send receive, but the 1 means that it only returns the 1 packet that responded, that is actually a valid response to the packet that we send. I kept the timeouts here on this to 2, very, very short timeout, because I was testing it on my local LAN here in the house, and with all these addresses to scan, this scan runs fairly slowly. So I try to improve the timing by reducing the timeout. Anyhow, we send out our packet. SR1 will give us the 1 packet that is the response, if we got a response at all. We check down here and say, did we get a response? If it's not none, then print, if we did get the response, then print a message that that IP is up. All right. So the main program then looks similar to what it did before in cycle 5, except that now we have this option added to add the ping, and we've also added some error checking in here to say, hey, if they specify the rscan option, make sure that they also specified some ports to scan. All right. And that's the run through of the source code. Our next video, we will demonstrate these features.